Right now, in the middle of the Pacific Ocean, the planet is doing something that should stop you in your tracks. One of the most active volcanoes on Earth is throwing lava 1,000 feet into the sky for the 54th time in under 2 years, a rhythm of eruption never recorded before in modern history. At the same time, a volcano in the South Pacific has just blasted an ash cloud so high it punched clean through the weather itself, so violent that scientists on the other side of the ocean briefly feared it might trigger a tsunami. And swirling between them, a whole armada of cyclones is spinning across the same warm waters, feeding on an ocean that just shattered its all-time heat record. If you want to understand what's really happening to our planet this week, and why so many extremes are stacking up at once, stay with me and hit subscribe to W for weather, because this story is unfolding faster than almost anyone realizes. Let's begin with Hawaii, because what Kīlauea is doing right now is genuinely historic. On August the 25th, 2026, the volcano roared back to life with its 54th eruptive episode since December of 2024. 54 separate lava fountaining episodes in a span of only about a year and 8 months. To understand why volcanologists are paying such close attention, you have to compare it to the last time Kīlauea behaved like this. Back in the 1980s, during the early years of the Long Pu'uo eruption, the volcano produced a famous series of lava fountains, dozens of episodes, but those unfolded across roughly 3 years. This new sequence has crammed even more episodes into far less time. The volcano is recharging and erupting over and over, at a pace that keeps setting new records with each cycle. This latest episode was a spectacle. The magma had been quietly refilling the system for about 12 days since the previous episode ended, building pressure underground, like air being pumped into a balloon. Then it let go. According to the United States Geological Survey's Hawaiian Volcano Observatory, the tallest lava fountains from the north vent reached roughly 500 feet above the ground, with the highest bursts observed around midday local time, and the ash and gas plume above it climbed to about 17,000 feet. Some observers on the ground reported individual jets spiking even higher in brief, dramatic pulses. Picture that for a second. A fountain of molten rock, heated to well over 2,000 degrees, rising as tall as a 50-story building, then falling back to the earth in glowing sheets. What tends to happen with these episodes follows a pattern, and once you know it, you can practically read the volcano's mood. First, there's an overflow, a spilling over of lava at the vent. Then the real event begins, and the opening act is usually the most violent. The very biggest fountains often come early, right at the start, hurling enormous chunks of molten and semi-solid rock, the pieces geologists call volcanic bombs, raining down around the vent. Then, over the following hours, the fury settles. The fountains drop from that peak height down to something calmer, and the episode gradually winds down. This one was expected to run for around 10 hours from start to finish before quieting again. One of the most surreal details from an eruption like this is something most people never expect. The intense heat pouring off the lava can generate small whirlwinds, spinning vortices of hot air that dance across the landscape near the vent, sometimes climbing the slope and merging into the larger rising plume. They look like miniature tornadoes born from fire. It's a vivid reminder that a volcano isn't just spilling rock. It's a raw engine of energy powerful enough to bend the air itself into spirals. Now here's where it gets more serious, and where the story turns from spectacle to genuine concern. Beneath the surface, scientists track something called ground tilt, essentially measuring how the volcano swells and deflates as magma moves in and out. As the summit erupts, the tilt drops, the ground deflating like a balloon losing air. But there's a second location that matters enormously, and that's the East Rift Zone. If you remember any single fact about Kilauea's recent history, remember this. In 2018, magma drained out of the summit and forced its way down into the lower East Rift Zone, and the result was catastrophic. Lava tore through neighborhoods in the Puna district, destroying around 700 homes, displacing more than 2,000 people, burying 30 miles of road, and adding hundreds of acres of brand new land to the island where the lava met the sea. So when instruments recently detected an uptick of activity along that same East Rift Zone, following a magnitude 5.2 earthquake at an offshore seamount that's part of the broader Hawaiian volcanic system, it caught people's attention immediately. It appeared as a small pulse of inflation right before the 53rd episode, almost as if a slug of magma pushed through the rift and helped trigger the summit to erupt. To be clear, this is nothing like 2018 in scale, and there's no immediate danger being forecast for those neighborhoods. But it's precisely the kind of subtle signal that observers watch with great care, because the volcano has shown before exactly how much damage it can do when magma decides to travel down that path instead of erupting harmlessly at the summit. Let me pause here and ask you something, because I'm genuinely curious what you think. If you lived on the Big Island, in the shadow of a volcano that erupts on a near-monthly rhythm, would you find it terrifying? Or would you find a strange kind of peace in living so close to the raw power of the planet? Drop your honest answer in the comments, because there's no wrong response, and the perspectives people share on this always fascinate me. Now let's cross the ocean, because while Hawaii was fountaining lava, something even more explosive was happening thousands of miles to the southwest, in the island nation of Vanuatu. On August the 24th, a volcano called Ambae, sometimes spelled Aoba, erupted with staggering force. This is Vanuatu's largest active shield volcano, and it shares a family resemblance with Kīlauea, built from broad, gently sloping flows of fluid lava. But Ambae has a feature that makes it far more dangerous when it wakes up. Its summit holds a crater lake. When rising magma meets that water, the result can be violently explosive as the water flashes instantly to steam and blows the eruption sky high. And that's exactly what happened. The eruption sent an ash plume soaring to around 15 kilometers, which is roughly 50,000 feet, punching straight up through the ordinary weather of the troposphere and into the stratosphere above. You can actually see how extreme this was in the satellite imagery. Because the plume broke through the normal cloud layers and reached such extraordinary heights, it showed up brilliantly against the night sky, bright and sharp, standing apart from everything around it. The eruption began in darkness, and it was so powerful that when detection systems picked it up, there were immediate concerns about whether it could generate a tsunami. That single fact tells you how serious this was. Tsunami fears don't accompany minor eruptions. Based on the available records, this appears to be one of the most powerful eruptions Ambae has produced in its documented history, and quite possibly the largest on record. That's a striking claim, so let me give you the context that makes it meaningful. Ambae has erupted seriously before. Back in 2017 and 2018, major activity forced the evacuation of the entire island, around 11,000 residents, as ash plumes climbed to roughly 10 to 12 kilometers. Those eruptions brought acid rain, destroyed crops, and released significant amounts of sulfur dioxide. There was similar major activity in the mid-2000s, again with ash reaching 10 to 12 kilometers, and scattered notable eruptions stretching back into the 1990s and, in the historical record, as far back as the 1800s. So this volcano has a temper, but the eruption on the 24th, reaching 15 kilometers, appears to have surpassed all of those. And as of the reporting, it wasn't a single brief blast. It was still going, still smoking, still erupting as the sun came up the next morning and revealed vast quantities of ash pouring from the summit. So take a step back and picture the Pacific right now as a whole. Kīlauea is fountaining lava in the north, Ambae is blasting the stratosphere in the south, and this all comes in a year that already saw a massive eruption earlier on, one of the biggest of 2026, which has since quieted down. The Pacific Ring of Fire is living up to its name. But the volcanoes are only half of the story because spinning across those same warm waters is an extraordinary amount of tropical activity. Hawaii itself was recently brushed by a hurricane that continued churning out in the northern Pacific, spinning with that classic counterclockwise rotation. And it had plenty of company. There were tropical systems off the coast of Baja California, where warm water was feeding storm after storm, with named systems even absorbing the remnants of one another as they wandered. There were clusters of disturbances near Guam, where the sea was running exceptionally warm. There was a tropical depression sweeping through the Philippine Sea. And there was a powerful typhoon that tracked past the southern islands of Japan and set its sights on China, forecast to make landfall within days of the peak of all this activity. This concentration of cyclones in the Pacific is not random, and it's not a coincidence. It's one of the classic fingerprints of El Niño, and understanding why is the key that unlocks this entire week. El Niño is a natural climate pattern where the central and eastern Pacific Ocean becomes unusually warm. That warmth changes the behavior of the atmosphere across the whole planet, and one of its signature effects is a shift in where tropical storms form. During El Niño, activity tends to ramp up across the Pacific, while it gets suppressed over in the Atlantic, and there's solid science behind that suppression. El Niño increases what meteorologists call vertical wind shear over the Atlantic, which is a change in wind speed and direction with height. Strong wind shear tears developing storms apart before they can organize, essentially decapitating them as they try to grow. It also promotes more sinking air over the Atlantic, which discourages the towering thunderstorms hurricanes need. So while the Pacific roars, the Atlantic often stays comparatively quiet. And that's roughly the pattern we've been seeing. Now, here's the part that has forecasters genuinely stirred up. This isn't shaping up to be an ordinary El Niño. The ocean has been running astonishingly hot. On August the 22nd, 2026, the global average sea surface temperature reached a new all-time record of around 21.1 degrees Celsius, surpassing every previous measurement in the modern record. And NOAA's Climate Prediction Center has issued a striking forecast. As of August 2026, they put the odds at greater than 90% that this will become a very strong El Niño event during the Northern Hemisphere fall and winter of 2026 into 2027. Some of their analysis even flags a meaningful chance that this event could exceed the strength of previous record El Niños. The various computer models suggest the warmth in the key monitoring region could peak at extraordinary levels. In the world of climate tracking, that is not a small deal. That is the kind of forecast that makes scientists sit up straight. And here's a crucial point about timing that a lot of people miss. It's only the end of August. El Niño events almost always peak later, typically around October, November, December, and into January. So if the Pacific is already this energized, this loaded with warmth and cyclones and record-breaking heat while the event is still building, then the truly dramatic stretch is likely still ahead of us. We are watching the opening chapter, not the climax. Now, I want to be very careful and very honest with you here, because this is exactly where a lot of online coverage takes a wrong turn, and I refuse to mislead you. It is tempting to look at all these volcanoes erupting at the same time as the ocean hits record heat and conclude that the volcanoes are somehow driving the El Niño, or that the El Niño is triggering the volcanoes. Some people speculate that undersea volcanic activity we can't even see might be quietly warming the ocean, or that carbon dioxide from underwater volcanoes is a major climate driver. It's an interesting thing to wonder about, and it's true that undersea volcanoes do release gases. But the established science is clear on the scale of this. The heat content of the ocean and the record sea surface temperatures are overwhelmingly explained by the atmosphere trapping more of the sun's energy, not by volcanic heat rising from the seafloor. Scientific assessments consistently find that human-produced carbon dioxide vastly outweighs all volcanic emissions, on land and undersea combined, by a wide margin. So, while it's fine to be curious about hidden connections, the honest answer is that there's no established evidence that volcanoes are behind this El Niño, or that this El Niño is causing the eruptions. When many dramatic things happen at once, our minds crave a single story that links them all. Nature doesn't always cooperate with that craving, and a good investigator has to be willing to say so. What we can say with confidence is that a super El Niño carries very real and very serious consequences, and history proves it. There's a deep and well-documented connection between the strongest El Niño events in drought, crop failure, wildfire, and famine. The most sobering example in the historical record is the Great El Niño of 1876 to 1878. That event unleashed catastrophic droughts across India, China, Brazil, and parts of Africa. And the resulting famines killed somewhere between 30 and 50 million people, according to modern historical research, an almost unimaginable toll representing several percent of the entire human population at the time. It reshaped nations and hardened inequalities that echoed for generations. That is the extreme end of what a powerful El Niño can do when it collides with vulnerable food systems. We are far better prepared today, with global food networks and early warning systems, but the raw climatic power behind those historic disasters is the same force building in the Pacific right now. More recently, the strong El Niño of 2015 into 2016 caused widespread coral bleaching, droughts, and disruptions around the world, and the current event is running warmer than that one at the same point in its development. And here's a detail worth holding on to. Some of these historic super El Niños didn't behave as neat one-year events. They came in pulses and rhythms, stretching their influence across multiple years. So this may not be a single season we simply wait out. It could have a longer tail than many expect. There's one more piece of the picture that concerns climate scientists, and it's subtle but important. When you look at the long-term record of global ocean temperature, it normally follows a predictable annual rhythm, rising and falling in a familiar seasonal pattern. But recently, that rhythm has appeared to shift out of phase, with the temperature peak arriving at an unusual point in the year. A shift like that is a signal that the climate system itself may be moving into a new state, and the Super El Niño is best understood not as the cause of that shift, but as a symptom of it, a dramatic expression of a system that's absorbing more energy than it's releasing. El Niño and its cooler sibling La Niña are a natural back and forth that has always existed, but how extreme they become is one of the clearest indicators of where the whole system is heading. That brings us to the sky above, because this same week has been unusually active up there too. As I covered in an earlier update, the sun fired off 5 M-class solar flares in a short span, including a strong M6.9, and there's a solar storm, actually a pair of them, inbound toward Earth. NOAA issued geomagnetic storm watches, with impact expected around the 28th of August, potentially reaching moderate storm levels. When these charged particles arrive, they energize the upper atmosphere and can produce beautiful auroras at lower latitudes than usual, along with minor effects on radio and power systems. Now, you'll sometimes hear people suggest that this solar activity is what's stirring up the volcanoes, the earthquakes, and the wild weather all at once. I have to be straight with you again. There is no established scientific evidence that solar flares trigger eruptions or earthquakes, and studies find no reliable link. It's a fascinating idea, and the timing this week is striking, but striking timing is not proof. So I'll flag it as an open question and an interesting coincidence, not a demonstrated cause, because you deserve the honest version. Down here on the surface, the heat is relentless. A significant heat wave has been baking Southern California, and there's a subtle detail about heat waves that reveals just how much energy is loaded into the system right now. Normally, high humidity makes it harder for the air temperature to climb, because water absorbs a tremendous amount of energy before it warms. It takes far more energy to heat moist air than dry air. So when a region manages to have both high humidity and a punishing heat wave at the same time, that combination tells you something important. It means there is an enormous amount of energy in the system, so much that even the moderating effect of all that moisture in the air can't hold the temperature down. That is the fingerprint of an energy imbalance, of a planet taking in more energy from the sun than it's able to radiate back out into space. And that imbalance is the thread that ties this entire week together, from the ocean to the sky. The Earth constantly radiates heat outward as infrared energy while absorbing energy from the sun. When we add more greenhouse gases to the atmosphere, we thicken the blanket that traps outgoing heat, tilting the balance toward warming. This is the engine underneath the record ocean temperatures, the supercharged El Niño, and the ferocity of the storms feeding on that warm water. It's not that any single event proves anything on its own. It's that when you line them all up, they point in a consistent direction. Here's a question I want you to sit with, and I'd love to read your thoughts in the comments. When you look at all of this together, the record ocean heat, the historic run of eruptions, the crowded Pacific full of cyclones, do you think we're witnessing a genuinely new chapter for our planet? Or a dramatic, but ultimately temporary swing that will settle back down? There's real debate among thoughtful people on exactly how to weigh natural cycles against long-term change, and I want to hear where you land. There's a strange irony buried in all of this that's worth ending on. Powerful volcanic eruptions, the very same events causing so much disruption, can, under the right conditions, actually cool the planet, at least temporarily. When a truly massive eruption injects enough sulfur dioxide high into the stratosphere, that gas forms a fine haze of tiny particles that reflect sunlight back into space before it ever reaches the ground. History has seen this happen. Large eruptions have measurably dropped global temperatures for a year or two afterward. It's part of why some people half-jokingly wonder whether a big eruption might buy the climate a little breathing room. But that's a devil's bargain, because the same eruption that cools the planet also devastates the region around it and disrupts agriculture and lives. There are periods in ancient history, like the turbulent end of the Bronze Age, where earthquakes, eruptions, drought, and famine seem to have clustered together, driving mass migrations and reshaping civilizations. It's a reminder that these forces have always shaped the human story, and they always will. So let's pull the threads together. Kīlauea has just completed its 54th eruptive episode in under 2 years. An unprecedented drumbeat of activity, with lava fountains reaching 500 feet, and a subtle signal along the East Rift Zone that keeps scientists watchful. Ambae volcano in Vanuatu has produced what appears to be the largest eruption in its recorded history, punching ash 15 kilometers into the stratosphere and briefly raising tsunami fears. The Pacific is crowded with cyclones, the classic signature of El Niño, while the Atlantic stays comparatively quiet thanks to wind shear. The global ocean has just hit its hottest temperature ever recorded, and NOAA gives better than 90% odds that this El Niño becomes a very strong event that could rival the most extreme on record, with its peak still months away. And overhead, the sun has been throwing flares and storms our way, adding to a week that feels charged from the ocean floor to the edge of space. Every one of those statements is grounded in verified reporting from agencies like the USGS and NOAA. What I won't do is pretend we know how they all connect, because the honest truth is that some of them are linked by clear science and others are simply happening at the same time. The discipline is in telling the difference, in staying curious about the patterns, while refusing to invent causes that the evidence doesn't support. That balance, curiosity paired with honesty, is the whole point of watching our planet closely. What comes next is genuinely uncertain, and that's what makes this such a compelling moment to be paying attention. Kīlauea will almost certainly erupt again in a couple of weeks, continuing its record-breaking rhythm. The El Niño will keep strengthening as we head into autumn, and we'll learn whether it truly rewrites the record books. The storms will keep spinning across that impossibly warm water, and the story will keep evolving in ways none of us can fully predict, which is exactly why it's worth following in real time rather than reading about it after the fact. If this deep dive helped you make sense of a chaotic week on planet Earth, do me a favor and hit that like button, because it genuinely helps more people find clear, honest coverage instead of the fear and hype that dominates so much of what's out there. Subscribe to W for weather so you don't miss what happens next, because I'll be tracking every development, from the next Kīlauea episode to the peak of this super El Niño to whatever the sun decides to do. And drop a comment with your thoughts on everything we covered, because the conversation you all bring is genuinely one of the best parts of this channel. Take care of yourselves out there, keep looking up and looking around, and I'll see you in the next one.